This is video 1.8. Today we're going to be reviewing transformations. Hopefully you've done transformations and remember them from geometry, where you have translations, which is a slide, reflections, which are a flip. We're going to be adding compressions and stretches to our translations and our reflections. All right, so we're going to start with translations. A translation is just a slide. Whenever you move something with a translation, you are taking it and you're moving it in the same direction a specific distance. So we are going to perform some translations on a point that is going to be at 2, -1, and then we want to give the coordinates of the translated point and see if we can identify some quick ways to find out what our new coordinates would be without actually graphing it. So the first one we're going to do is we're going to move it 4 units to the left. So here's our graph. We're going to graph it at 2, -1, which is right here. We want to move left 4 units. So we want to move it 1, 2, 3, 4. Right? So that's where we are going to slide it over to 4 units. So our new point should be at -2, -1. If our original was at 2, -1, which coordinate changed when we were moving it left? Just our x changed, right? And it changed by 4. So we moved left, so it's like we subtracted 4 like you would on a number line, which would give us a -2. Let's say we moved it to the right 3 places. What would our new coordinate be? So if we're going to move it right, rather than subtracting 3, we would add 3 just to our x coordinate. Should be at a 5, -1. So let's try that. We're going to move it 1, 2, 3. That will be our new spot. And it is at 5, -1. So what happens then, do you think, if we move it up and down? Let's start out with our 2, -1 right here. We're going to shift it 2 units to the right. So we're going to shift it here. And then 3 units up. 1, 2, 3. So here's where our new point would be. That's where our transformation is going to take place. Our new point is at 4, 2. We should be able to see that what that is our x value plus our shift and our y value plus our shift, which would be 4, 2. So shifting up adds it, shifting down subtracts it. So reflection is just going to be a flip. There are 2 ways that we're going to talk about doing it. It's reflecting it across the y-axis. When you do that, your x coordinate changes. So for example, let's say we had the point 1, 2. And we were wanting to flip that across the y-axis. So that means that it needs to be exactly as far away from the y-axis as the original. So we're 1 spot away, so we're going to put our new spot right there. All right, so our x coordinate changed, our y did not. So our y was at 1, 2, and our new spot is going to be at -1, 2. So you can see that our x coordinate is the only thing that changed. If you were reflected across the x-axis, it's going to be the same thing. So let's go back and have our same point. We've got our point at 1, 2, and we're going to reflect across the x-axis, which means we're going to go down here. So it should be right here because that's 2 spots away. And so 2 spots away would be right there. And our new point would be at 1, -2. Whoops. Put a -1. It shouldn't be a -1. It's just a 1, -2. Our y coordinate is what changed. And they should be identical because what it is it's how far away from that center line you are. And so all you're doing is taking the opposite of your number. So let's look at some translating and reflecting of functions. So we're going to use a table to show each transformation, and then we're going to graph it. So we're going to translate this first one 2 units down. Here is our graph that we are going to translate. So we're going to make a table first. So we want to take a few key points. I've gone ahead and labeled them on here for us. So we're going to make a table. I'm going to do my X and my Y for my original, and then my new one is 2 units down, which means I change my Y value. So my X isn't going to change, but my Y is. My Y is going down 2, so I'm going to subtract 2. So my X here is at -2, and the Y is at 4. This one, next point is at -1, 0. The next point is at 0, 2. And then the next point is at 2, 2. So all I'm changing is my Y value. So my new Y would be, this will be 4 minus 2, which is 2. 0 minus 2, which is -2. 2 minus 2, which is 0. And 2 minus 2, which is 0. Let me change pen colors. Let's go purple. I'm going to plot my new point. So at -2, instead of being at 4, it's going to be at 2. So here's my new point. At -1, instead of 0, it's going to be -2. So it's going to come down here. At 2, 0, instead of 2, it will be at 0, 0. So we're going to go here. And then the other one will go right here. So here's our new line, shifted down by 2 units. Let's do one where we reflect it. So we are going to do the same thing, only this time we're going to reflect it across the y-axis. All right, so we have a few less points just because I took off what was on the other side of the y-axis so that we can reflect it correctly. So a reflection across the y-axis means that your x changes, right? So I'm going to have my x and my y, and this time, if you'll recall, all it's going to be is we change the sign of the x, right? So here our points were -2, 4, -1, 0, and 0, 2. So my new x, if I'm going to take the opposite of that, is going to be a 2. So that means my point would be at 2, 4. My -1 is going to become a +1, so it will be right here. And then my 0, can't really change the sign of a 0, so it overlaps it. So here is the reflection across the y-axis. So we're going to talk about stretches and compressions now. A stretch is when your factors are multiplied. It's going to make it bigger, or it's going to make it either horizontally, it'll pull away from the y-axis. That's when your x-coordinate changes by a multiple. And your y-coordinate will change if you're pulling away from the x-axis, which will make something taller. So that's a stretch. So if we take, let's just say we have a parabola here. If we were going to stretch it, and let's just pretend that my zeros here are at, let's say one of them is at 4, 0. So my stretch would be, if I wanted it 2 times bigger, then I would do at 2 times 4, and my 0 would stay at 0, so that my new point would be way over here, so that it would be much wider. Okay, so that would be a stretch. A vertical stretch, if we have our parabola here, and we're changing our y-coordinate, so let's say this was at 0, 4, and we were wanting to make it 3 times bigger, then this would be at 0, 12, because we would do 4 times 3, right? So our new point would be way up here, meaning all our other points are going to stay the same, but our y values are going to be a little different. So actually when it stretches, it's going to change all your y values, so it's going to make it kind of skinnier. There. So a compression is when you multiply or you divide. So like a 1/2 is going to end up being a compression, because it's dividing it by 2. So when you do a horizontal one, your x-coordinate changes. So let's go back to our parabola here. If we did it by 1/2, it's going to get skinnier. So there's our new one. Because if these were our points was at 4, 0, then you would do 4 times 1/2 as your new point. So your new point would be at 2, 0. That would be your transformation. So for a vertical compression, if we're back to our parabola here, then what it's going to do is it's going to get toward the x-axis. So let's say, well, let's go back to our 0, 4 over here, and let's say we have a vertical compression of 1/2. So we're going to multiply that 4 by 1/2, so that our new point would be at 0, 2. So from right here, it's going to squeeze down a little bit. When it does, it's actually going to end up coming a little bit wider, sort of like that. There's a good picture and chart in your book on page 61 if you want to see their examples. So let's stretch or compress this one. So actually this one's going to be a compression because we want a factor of 1/2. So we're going to start with our table. Start with my x and my y here. So I'm going to write down my x points. It's at -1, 3, 0, 0, 2, 2, and 4, 2. So I'm looking for a horizontal compression. Horizontal means that my x coordinate changes, so my y does not. So I'm going to take my x's and I'm going to multiply them by 1/2. So I'm going to do 1/2 x. So 1/2 of -1 is -1/2. 1/2 of 0 is 0. 1/2 of 2 is 1. 1/2 of 4 is 2. So my new points, these are my new x's, and these are my y's. So I'm going to go to a -1/2 and go up to 3. So you can see that that's a little closer to the axis there, my y-axis, which is what I'm wanting. I'm compressing toward my y-axis. Since it's horizontal, I'm going y. At 0, 0, so that one doesn't change. And then at 2, I'm going to be at, at 1, I'll be at 2. And then at 2, I'll be at 2. So here's where my graph would be there. So that it squeezes into that y-axis. When you come to class, we'll do a lot more practice with these, and you can get to where you can see what is going to happen to them as they go. Just interesting to see how your numbers change by just doing a little bit of a transformation on your function. Hope you have a good night, and I'll see you later.